You just checked your phone. Maybe it was 30 seconds ago. Maybe it was 5 minutes ago. But at some point in the last hour, your hand moved without asking your brain for permission. You picked it up, you scrolled, you put it down. And then, a few minutes later, you did it again. You probably told yourself you were just checking the time. But the real answer for why you did that is far stranger than laziness or bad habits. It reaches back into the deepest architecture of the human brain, into systems that were built millions of years before the screen existed. Your phone is not the problem. Your phone is just the newest object that knows exactly how to talk to a part of you that is very, very old. Here is what is actually happening. Deep inside your brain, tucked beneath the thinking and reasoning layers you use every day, there is a structure called the nucleus accumbens. It is part of your brain's reward circuit, and it has one job: not to make you happy, to make you want. Neuroscientist Kent Berridge at the University of Michigan spent years carefully mapping the difference between liking and wanting, and what he found changes everything about how you understand yourself. Liking and wanting are run by completely separate systems. You can want something intensely and feel almost nothing when you get it. You can get something and like it and still want more the moment it is gone. The wanting system runs on dopamine, and the wanting system never gets satisfied. It only gets louder. Every time you look at your phone and there is something new, dopamine fires. A notification, a like, a message, a new post. Each one is small, each one is quick, but small and quick is exactly what that circuit was built for. Not for a long, reliable, guaranteed reward. For something unpredictable, something that might be there or might not. Psychologist B.F. Skinner discovered this in the mid-20th century when he was studying pigeons. He put them in boxes where pressing a lever produced food. When the food came every single time, the pigeons pressed steadily and then stopped when they were full. Normal, predictable. But when Skinner set the lever to deliver food only sometimes, randomly, with no pattern the pigeon could learn, something strange happened. The pigeons pressed the lever obsessively. They could not stop. The unpredictability did not reduce the behavior. It intensified it beyond anything the guaranteed reward had ever produced. Skinner called this a variable ratio reinforcement schedule, and it is the single most powerful behavior shaping mechanism ever discovered in any species. Your phone runs on a variable ratio reinforcement schedule. Every time you pick it up, you might find something meaningful, or you might not. You never know which one it will be. And that uncertainty is not a flaw in the design. That uncertainty is the engine, but it goes even deeper than dopamine. There is another system at work, a system that is not about reward at all. It is about threat detection. Your ancestors did not live in a world that was mostly safe. They lived in a world where missing information could kill you. A rustle in the grass, a silence where there should have been sound, a shift in the behavior of the group. Every piece of information was potentially survival relevant. The brain that survived was not the one that waited comfortably for updates. It was the one that kept scanning. That checked again. That could not relax until it knew. Neuroscientist Matthew Walker, author of research on sleep and brain function, has described how this threat detection system, the amygdala, stays active even when there is no threat present. It does not require evidence to fire. It requires uncertainty. Uncertainty itself is the trigger. And what does a phone that might have a new message on it represent? At the level of your ancient threat detection circuitry, unresolved uncertainty. Something that might have changed. Something you have not checked yet. So when you reach for your phone for no clear reason, you are not being weak. You are being human. The behavior is a perfect translation of a survival mechanism into a modern environment it was never designed for. The word for this mismatch is evolutionary mismatch. It is what happens when a piece of ancient biological code runs in a context it did not evolve to handle. Your craving for sugar is an evolutionary mismatch. Your stress response to a work email is an evolutionary mismatch. And your compulsive phone checking is an evolutionary mismatch. The hardware is ancient. The software it is running is new, and they do not always get along. But it is even more specific than general unpredictability and threat detection. The phone activates something else, something that humans are almost uniquely obsessed with, more than almost any other animal. Social information. Psychologist Robin Dunbar at the University of Oxford spent decades studying the relationship between primate brain size and social group size. His finding was remarkable. Across primate species, the bigger the neocortex relative to the rest of the brain, the larger the social group the animal could maintain. And humans, with by far the largest relative neocortex, could maintain relationships with up to about 150 people simultaneously. a number now called Dunbar's number. The human brain did not get big to solve abstract math problems. It got big, at least in part, to track people. Who is allied with whom? Who is rising in status? Who is angry? Who is in trouble? Who has disappeared? Social information was survival information. Being excluded from a group in the ancestral environment was not a social discomfort. It was a death sentence. And so your brain evolved to monitor social standing constantly, to crave updates about the people around you, to feel genuine physiological anxiety when you are not sure where you stand. Your phone delivers social information. Every notification, every like, every reply, every post in your feed is a social data point. Your brain processes it the same way it would have processed news about your tribe. And just like your ancestors could not afford to ignore a change in the group's behavior, your brain cannot cleanly ignore a new notification. This is why you check it. Not because you are addicted in the clinical sense, not because you have no willpower, but because your brain is doing exactly what it was built to do, in an environment that serves up social information faster and in greater volume than any environment in the history of the species. And there is one more layer that rarely gets talked about. It is boredom, or more precisely, the aversion to boredom. Psychologists Timothy Wilson and Daniel Gilbert at Harvard and Virginia ran a series of experiments in which they put people in a room with nothing in it and gave them the option to sit quietly or press a button to administer a mild electric shock to themselves. The majority of participants chose the shock. Given the choice between an empty mind and a small pain, most people chose the pain. Your brain does not experience mental stillness as rest. It experiences it as danger. An idle mind in the ancestral world was a mind that was not scanning for threats, not tracking social dynamics, not solving problems. The brain that could tolerate boredom may have been the brain that got eaten. So your phone is not competing with your self-discipline. It is competing with silence itself. And you were built at a fundamental level to lose that contest. Knowing this does not fix it, but it changes what the problem actually is. You are not failing at self-control. You are succeeding at being the kind of brain that survived long enough to build a phone in the first place. The question is not how to stop being human. The question is how to design your environment so that the ancient brain you are running does not run the entire show. Because right now, on the other side of that screen, there are teams of engineers who understand exactly how your nucleus accumbens works, exactly how your threat detection system fires, exactly how your social monitoring circuits crave updates, and they are very, very good at talking to those systems. You cannot out-willpower a machine that has been designed to speak your brain's oldest language, but you can make the machine harder to reach. You can interrupt the automatic reach before the dopamine loop closes. You can create friction between the impulse and the action. You can train your attention slowly, imperfectly, the way a body gets stronger by choosing discomfort in small doses over time. Because the phone did not create the circuit. The phone just found it. And that circuit, the one that scans, that craves, that cannot rest until it knows, that is also the circuit that kept your ancestors alive in the dark, that drove them across continents and oceans, that made them build everything you have ever known. You just checked your phone 30 seconds ago, and now you know what actually reached for it.